All right, excellent. So welcome everybody to this very special TWed. Sola is going to be leading us in a discussion. He's going to be educating us on Wikidata and practitioners' use of Wikidata, which we're very excited. He's going to talk to us about the RPI instance of Wikidata and how he's used it. Just a couple of logistics. We are recording this this TWed. It's going to be up on the interwebs forever. So you'll take questions.
Yep. You can take questions as I'm going.
Yeah.
And, I think probably just taking questions as I'm going will be 10%. So.
And this recording is going to be up, available through the TWed's World site later. When the pizza arrives, quietly get up and grab the pizza. Thank you, Sola. Take it away.
Thanks. So as John has already mentioned, the main point of my talk is going to be on working with Wikidata. So really I'm going to be giving some kind of high-level ideas about really how to query the information in Wikidata, how the information is structured, and kind of just trying to give some inspiration for how the information that's present in Wikidata might be of use to you for your own project. And I'll also be trying to go through some somewhat more hands-on tasks of kind of working through some examples of queries and stuff as well. All right. So to start off, so what is Wikidata? So Wikidata is a very large-scale knowledge graph that's hosted on the web. It's open source, multilingual, and it is also community-driven. So much like Wikipedia, Wikidata is developed by the community. There's a number of bots that also do a lot of automated extraction from sources in Wikipedia as well. But for the most part, it is community-driven, and so actual members of the Wikidata community are making new additions, having discussions about changes, and so on. So it's a knowledge graph that has coverage of a lot of topics, and it's also constantly evolving because as new events occur, new people might go in and actually add entries about that new information. So some notable features of Wikidata, and I'll kind of describe the content of this picture a little bit as we go on, so don't worry too much about reading any of the fine print there, is that there are a lot of aspects of Wikidata that make it quite easy to access and browse content, at least on the scale of a few entities at a time. And again, it covers a very wide range of topics, so it's not necessarily one of these very specialized knowledge graphs or ontologies that only describe a very specific domain, but instead it covers an extremely broad range, which can be a good thing and it can be a bad thing, but we'll kind of return to that later. And another thing is that much like Wikipedia, statements that are present within Wikidata include references and qualifiers. So in this example here, for these properties, such as how Douglas Adams was educated at St. John's College, there's some qualifiers such as the start and end time, as well as the major of his education there. And there's also references that are used to actually point to the source that people use when they entered that information. And across Wikidata, a lot of things are also documented relatively well. In some aspects, it's not documented extremely well, and people don't necessarily follow the documentation extremely well either, since it's just community members again. But compared to a lot of other knowledge graphs and large-scale databases that are out there, it is documented well. So how do we actually go and use Wikidata? Well, first of all, it's way too large for you to try to keep a local copy. As of October of last year, there are over 100 million items within Wikidata. And last I checked, like the zipped version of Wikidata was like 100 gigabytes, and trying to extract it will crash your computer. There's a kind of graphic here showing some of the breakdown of the content that's within Wikidata. There are millions of entries for things like scholarly articles. I think that's actually the largest percentage here. So like 33% or 31% of the content is scholarly articles. A lot of these things are automatically populated as well. And so there's just a lot of content in there. And so instead of trying to, download a copy and use it yourself, instead what you should be doing is querying for what you need. So you can either do it on an ad hoc basis, just making a single query at a time. For example, here we're trying to get the label of whatever this entity is, which happens to be Professor McInnes. Or you could do a few queries and then try to download it so that you just have a subset of Wikidata that you can save on your local machine, and then that makes it much more manageable to do whatever other downstream processes you might want to do. So in this talk, once again, the main ideas that we'll be covering is the basics of how to query Wikidata, including some comparisons of the public query endpoint versus RPI's endpoint that you can use. some common prefixes and properties of interest that you probably want to know if you want to be doing queries over the information in Wikidata, as well as how to interpret and navigate the results that you actually get from your queries. In addition to these basics about the querying process, I'll also be discussing a few common problems that you probably will encounter, especially if you want to be querying for a relatively large amount of information, including some ways that you want to be avoiding bad queries, some examples of human error that you might encounter, and kind of just a reminder to keep your eye out for it, and also examples of some questionable query results and kind of the nature of those sorts of results that you might encounter as well if you're trying to programmatically query a large amount of data. So just to start off, for the actual endpoint that you can use to query Wikidata, there is an official Wikidata instance which you can query from this URL, and I'll share this presentation later for if you want to go back and check the links. But basically, this is the URL you want to be using if you want to send like an HTTP GET request to get information. There are some limitations on actually using this official SPARQL query endpoint from Wikidata, including maximum query time of 60 seconds. Additionally, you can only run 30 erroneous queries per minute. Can you? And you can also only have 5 parallel queries going at a time per hour. So these aspects can be relevant if you need to query a large amount of data, or if you have something like a SPARQL query built into some sort of pipeline that you're doing, you have to make sure that you aren't going over these limits. If you go over the limits, you will be temporarily banned from accessing it. My experience, that didn't last for very long, but it can still be an annoyance if you actively need to be using it. Now, on the other
like a
hand,
day, more than a day, less than a day, a few hours?
less than a day, I think a few hours, but I would imagine that if you like keep violating their limits, it probably will increase. But
Okay.
I know at a very small scale, it timed me out for like a very small amount of time, and after I kept repeating it, it started to get to like the hours. So, yeah, it's best to avoid it in general in the first place, but we'll discuss how to avoid the potential
The
issue.
cloud one has a limit? Is the cloud one that has a request limit? Just in general?
I think it's just in general.
Okay.
So on the other hand, we also have a Wikidata instance that's run at RPI. And so you can access that when you're on RPI's network, so either just on campus or through the VPN. And the URL is there. Once again, I'll be able to share that later. Some differences between the instance that's hosted at RPI and the official one are that RPI's instance only includes English labels, which could maybe make your life easier if you only care about the English labels. But if you do want to incorporate that multilingual aspect, that's going to be a limitation. There also are some missing entities, which partially is because of this last point, that it's not completely up to date with the official Wikidata. But it also does seem like there's some entities that are missing for unknown reasons, which maybe will be diagnosed at some point. But so the information that's on RPI's instance isn't complete, but there aren't going to be those same limits as the official public endpoint. So like if you need to do queries that are going to take longer, or if you need to actually do a very large amount of queries in a short amount of time, then trying to use RPI's instance could be.
Could you give an example of like what you think of as a missing entity on even the public?
Yeah, so I guess not even going to the public one, but just from RPI's, which this was an error that I encountered recently. There was like an example of a railway accident that occurred quite a long time ago. And that it kind of was part of the data that I was using that I originally had acquired from like the official Wikidata. But when I was checking, trying to query for it in RPI's instance, it just wasn't there. And part of the reason for why it wasn't there could include that it originally didn't have an English Wikipedia article. And so in the initial version of the Wikidata instance that was being set up, I think that that was one of the things that they were looking at, of like maybe only including things that had English Wikipedia.
Okay.
And so, yeah, in terms of like missing entities, I think that that's probably the biggest or most significant one of, if there isn't an English entry or an English label for the entity, I think that it probably doesn't exist within RPI's instance. And so this could potentially be problematic if there's like inconsistencies, or if there's some like relatively new event, like say there's the protests in Iran that have recently been starting. There's now a Wikidata entity for that, but that's probably not within RPI's instance because it was set up before that event.
Thank you.
Just the other thing is that when Sola referred to as like the official one,
Yeah.
is also heavily federated. And so there's that sourcing. Also, you'll notice as Sola goes through it, like everything has got like identifiers.
Yes.
Okay. And in some cases, something supposed like the labeling of those identifiers in a human-friendly way is actually federated.
Okay.
And so you might be working with an entity label, an entity identifier, but not have, and if you try to do a similar query on the main thing, the cloud hosted one, you might get a result which reflects the kind of a human friendly labeling. So it's kind of, does that match your experience?
Just a question. Is Wikidata, do they have like a release schedule, or as we contribute to the graph is automatically available? Like,
I believe that they do have a release schedule for like dumps that can be downloaded. As far as just accessing things on the web, I'm not actually sure about that. I would imagine that as soon as someone makes a new entry that it can be accessed.
just like Wikipedia, right?
Yeah.
Okay.
Yeah, I think it's just, it's just.
Okay.
Yeah.
And then do you know when is RPI data from? Like, how old?
It's summer.
Summer?
So because it's like what, like 100 gigabytes or something, some outrageous thing. It's a real, it's like a two-step process. One is just getting hold of that entire archive, and then the
point.
dehydration of it in the form of so it's a non-trivial thing for us to do. And
So it's like 8 months old.
right. So the question is why do it? And I don't know if we discussed this at all, but
Okay.
why would you have a local instance? Sola was first, local. Okay. Why would you have like an institutionally hosted thing? And typically it's because your research group is augmenting it in some unique way. That's typically why we're kind of doing it, because we're RPI, because Jim Hendler is Jim Hendler, and we want to represent. But we want to know about it. We want to understand. We want to use it. We want to do more than just be any other user.
Right.
That's kind of why we're doing it.
Yeah, and thanks for the discussion. I don't really touch on that aspect in the rest of my talk. I've kind of been focusing more on what really you can get from the public, like official endpoint. But yeah.
There you go. Now we see actually how to use it.
So I'll kind of skip over this quickly, but this is just like an example for future reference for if anyone wants to like use this implementation. If you want to do a query, you can just use a simple HTTP GET request. For example, here you set the URL as say the public Wikidata SPARQL query endpoint. Set your query just using basic SPARQL, and then send your GET request. You get your response, and then you can format that as JSON, and then do whatever you want with it. So you can either just print out results if you're trying to do that, or you can save it so that you have like your own local subset of it, and so. Oh, yeah. Sorry.
Is it rate limiting for the query part, or where you grab the JSON object? Because I think Wikidata has a thing where you like go on a page, you just add like .json, and you can just get the raw like JSON object, right?
Yeah.
Is there a limit to that as well, or?
I'm not sure about that. I would assume that the rate limit would be the same, but like just going and clicking like to get a JSON from a web page and doing this sort of query would be a little bit different in terms of that access. But I would imagine that they would probably have a similar.
Try it, find out.
I was trying to get it so complicated.
This is just another example that I'll skip over even more quickly. For example, rather than just doing a request, there's also packages like SPARQL wrapper within a Python, which probably works more nicely with RDF lib and stuff if you're using that in your pipeline. But here's just an example of getting the exact same result as JSON instead, and URL is switched in. So having kind of breezed over how to use HTTP GET requests and stuff to kind of query it more programmatically, if you're more interested in exploring just the content within Wikidata and doing it a little bit more manually, which we'll be doing today so that we can actually understand information, There's also a public query service online that's hosted by Wikidata, which I already showed there. And so this is very nice because you can do your SPARQL queries here and then just get results. So actually, I'll go back over here. So you can do a query, get a bunch of results. But there's also a lot of additional help information that's available from this website. So you can link to the help portal, which has a lot of information about Wikidata, which I won't cover because it's a little too extensive. There's also user manuals in general, links to how to do SPARQL if you're not familiar with that, as well as example queries. And for the example queries, you actually can directly import them into this editor right here. For example, this is a query about getting cats. And then you can just run the examples directly from here as well. And so that's very convenient. And in the results that are returned here, you can also just click on them directly to go to the web page. This is some cat. And also within this actual UI for constructing the queries, if you hover over it, relevant properties or instant items that you actually entered into your query, it also gives you some information. So especially if you're still getting started with it, using this query service to kind of explore as you're going can be very helpful. And then separately from that, for RPI's instance, if you want to use this sort of an interface, there is a Blaze graphic query that you can do. For example, here you just execute it, you get a response. There's also a history of queries that people have done, probably mostly me. And you can kind of do some similar things, but it doesn't give you quite as much hand-holding in terms of like providing with examples and stuff. So if you want to be going through, especially as a beginner, using the official query service probably is the way that you want to go. So now we'll kind of start going into examples of actually running queries. And to get started with that, I think that the following three prefixes within Wikidata are probably the most important for you to keep in mind. So the first prefix is WD, which basically is just any Wikidata entity, or as they describe it, I believe, items. So basically any page that actually is for a concrete entity. For example, one that they refer to a lot is this entity of Douglas Adams. This can be expressed as like WD colon Q42. And that would be the prefix that you would use for this.
So his entity ID is Q42.
Yep.
That's awesome.
And so the second prefix is WDT, which is for direct properties. And an example of this is, say, WDT P31, which is the instance of property. So if we scroll down here, for example, we can look, there's instance of. And also you can click on things like the properties and get more information about it. Instance of is basically Wikidata's equivalent of RDF type. But so WDT basically is what you want to be using when you're looking at direct properties that are connecting two entities together. And then lastly, this last one, P, is for just a property. And so this is similar to WDT in that they're both talking about properties. So say you could also describe the property instance of as like P colon P31. But rather than pointing to direct entities, properties that have this prefix actually are instead pointing to statements. And so we'll get back to that in a second as we step through a few other examples.
Good question. So do you know why they refrain from using RDF type?
I'm not sure. I'm sure that there's some discussion page on it since it is pretty well documented and there are.
Oh, I see like RDFS label is there. They use RDFS
Yeah.
label, right?
And actually, if you look at something like the instance of property, and they're like also known as, they refer to things like RDF type.
Okay.
And as far as I'm aware, so there are some spots where they use RDF type and RDFS label and stuff. Within these sorts of normal entries, I think that the only RDFS relation that's used is RDFS label for their names and such. But yeah, there's instance of, and also like the subclass of Wikidata uses their own version of that, like V279 or something, and then similar to instance of it, like has it also known as RDFS subclass, but they use their own property within the data.
I found the first time I got on Wikidata and the big site, it was really a challenge to do kind of the follow your nose exploration of the graph, because I was expecting certain things, and I wasn't. It's
So we're saying that they have.
probably every knowledge graph is opinionated in some way, right?
So basically saying that they have their own data modeling, for instance.
Yeah.
It should be that worldview.
The indirect.
And actually, come to think of it specifically for like the RDF type versus the instance of relation, like I think that typically the way that you would want to model things, RDF type is probably stricter than how Wikidata uses instance of. So that could also be part of their motive.
Okay.
So yeah, I'll step through a couple of examples now. So for example, if we want to do a query like what's the label for this entity here with the QID 4096, I already have this loaded up, and so we can run this. And this happens to be the entity for Will Smith. And so we can see a bunch of different labels in various languages. If you're querying on the RPI instance, it would only return the English one. But if you did want to say filter for English, that would be a just basic filtering that you would do similar to any other SPARQL query for literals related to them. And so next, what if we want to make a query like who is Will Smith's spouse? So in this case, we could try using the direct property, so WDT, and then P26, which I looked at stuff before, I happen to know is the spouse relation. So if we do T, ready, 6. We can also hover over this and see again that it's the spouse relation. Maybe that's a little small to see, but. And if we do this query, it returns this entity. And then if we click on this entity here to follow, we can see there's Jonathan Smith and all the various information there. So now what if instead of using the direct property prefix here of WDT, what if we use P? So recall that this is the just simple property and it's going to point to a statement. So now let's see what happens. So instead of WDT, we're going to change this prefix to P. Oh, and also another thing that I should have mentioned is that in this help, there's also a list of prefixes, which can be very helpful if you forget them at any point. There's a bunch of Wikidata specific ones. And so now if we run this query, we get these entities, which are some stringed hashes. If we click on them, we can see that it actually points to some entries within Will Smith's Wikidata entry page. And we can see there's pointing to 2 different individuals that have a different start and end time for this marriage. So what's going on here is that when we're using just the P prefix, so a property, it's pointing to statements. And under the hood within Wikidata, I believe that nearly everything is basically verified using these statements. So for example, instead of just having that someone is an instance of Q5, which is human, what's really modeled by Wikidata is that it has this statement, which is some hash, and then there's a rank related to that statement. There's provenance about that relation. And then that statement then points to the actual final entity here. So human once again. And so this is basically what allows Wikidata to include various qualifiers like the start and end time, as well as including references. So it uses the statement as an intermediary node that then points to other references and so on. And then also this aspect of ranks is relevant because it can be used to indicate which results are returned by the direct property. So if we see here, we actually can see that in this graphic, maybe it's a little bit small, but there's these 3 dots.
Yeah.
And then Jonathan Smith has this top dot, which is the preferred rank, whereas this one has normal rank. And so when we try to use that WDT prefix, which is the direct property, it would point to the preferred rank if there is a preferred, and otherwise it'll just point to various normal ranks that the relation might have. If we want to actually look at the results that are returned by something like this in the query, you can see here. So for example, this is the first statement that's for, this is for Shada Smith, and we can see how this statement has a rank, which is the preferred rank. It also has this RDF type best rank. I'm not entirely sure what the point of having that extra RDF type is in there, but it's there. And then this, which is start time, the start time relation. And then it kind of points to this other thing, which is some other representation of the date time. But if we look here, with the different prefix, there's the same relation of start time. And this is a more human readable January 1st, 1997. So if we want to look at what the difference between these 2 prefixes is, we can, for example, go to the help list of prefixes. And then it's PQ and PQV. So PQ is a property qualifier, whereas PQV is the value of that qualifier. And so they have a few different levels of how they're actually representing all of this information. And similarly for the other statement, we have things like the start and end time, as well as the link to the actual person entity.
Do you know if the WDT is inferred or is it a real relationship? On that example, like WDT P31?
I believe that it would be inferred just because putting it in manually wouldn't really make sense. I think that in terms of how it could be inferred, it would be pretty straightforward, since if there's a best rank or preferred rank, that would always come up as it, and otherwise I think it just selects all of the normal rank entries. There's also a deprecated rank, which I think doesn't normally come out unless you really try to look for it, and I wasn't able to actually come across any examples of it, so you probably don't need to worry about it.
Do you think this reasoning is done before the release, the dump? So it's the dump as like as a triple?
As
Or
far as whether it's in the dump or not, I have no idea.
Okay.
I think that there are a couple of different versions of dumps, or at least when I was looking at it a while ago, I think there was like a truthy dump, which possibly only included the direct properties and also like just the preferred entries. But I'm not 100% sure if that's still the way they do the dumps.
So when you've got these different namespaces and essentially the same suffix, P31, so WDT P31, P31, PS P31. Sort of, when I first was doing Wikidata, I got into the how do you put stuff in the graph a little bit. Is it designed to create all of those at the same time, all of the objects for those assertions at the same time? So you're creating a WDT P31 assertion, the PS P31 assertion, P31 assertion. Are those done sort of in unison? Because they're all, or is
If you mean in terms of like actually adding information to Wikidata, I'm not sure. But I would think that the way that it works most likely is that people enter statements, and then the statements can then lead to the inference about the WDT.
Okay,
because that's just
add the statement and okay,
Yeah.
got it, okay.
so like over here, this is basically the statement level information. And so I would imagine that in terms of like actually entering so like what the P31, so what instance of this statement refers to, as well as the reference for that, as well as maybe the rank goes in automatically if it's not specified as probably just normal rank.
Okay.
But I think that they're entered as statements, and then the WDT prefix information is inferred.
Okay, I get it. Okay, excellent.
Right, so now that we've kind of gone over what the statements are, so in terms of the benefits and drawbacks of the statements, so the statements can provide some valuable qualifiers for a very large number of properties. For example, as the example that we went through, there could be start and end times for marriages. This could be very relevant if you're, for example, trying to look at the history of like who people have been married to, or if you want to look at more complicated entities or properties. Qualifiers are also very frequently used within Wikidata to represent these slightly more complex content. So for example, the COVID-19 pandemic, there's an entry that it has effect of panic buying, but really there also was kind of some more qualifiers related to this. So there was panic buying of these specific items like toilet paper, hand sanitizer, and so on. And so if you were just looking at the direct property, all you would be able to see is that it has effect panic buying, whereas maybe it's relevant for you to be able to look at the, for example, other kinds of items that were involved with this panic buying. Now, on the other hand, in terms of drawbacks, really, I think that the biggest drawback is that if you're not really going to be using all of the information that's included within the statements, it becomes extremely clunky and it bloats your data in terms of like the storage.
So a question on panic buying, like are those things subclasses or like, instances of panic buying, or like how are they represented?
Yeah, so actually I guess that we can just go into a query directly here. So that was P. Barely see it from here. 2. Let's look at some of the effects. Oh, actually, this is the one. No. So I believe that it's not subclasses. It's not directly represented as subclasses, but rather for this statement, if I can actually find what panic bind is. 6. So for this statement, it has these various qualifiers. For example, this is just of. And so it gives a description of what it means by of, but just like the word of maybe isn't extremely descriptive, but it has these additional qualifiers within the statement. And so at least explicitly, it's not actually a subclass per se. I suppose that in some cases you could consider it to be like a subclass, but at least in terms of the modeling, no, it's
So it
just.
seems like panic buying is a subject of, and then the object, toilet paper, whatever. So it's another triple if you reify it.
So in terms of comparing it like to this image here, it would be, so there's a statement and then it's pointing to panic bind, and then all of the other items that are connected by this of relation are
Yeah.
sprouting out of this statement. So yeah.
So 2 statements there. Thank you.
So to go back to the point of the potential drawbacks of using statements. So again, if you're not using all of the information from the statements, it's going to increase the amount of data that you have by quite a lot, probably like at least 4 times as much information, since instead of the single triple, you now have a triple pointing to a statement, which has its rank, its reference, and the end object, as well as any other qualifiers that you need. And also a lot of algorithms and methods that work over knowledge graphs aren't really suitable for this sort of reified information. Most of the time, they just assume that there's the simple subject predicate object triples. And so if you're trying to run algorithms for say like knowledge graph completion methods, it probably is going to fail miserably if it actually has all of this additional information and the different ways that it's reified and uses this statement. So that's just something to keep in mind. But on the other hand, if you can actually make use of the statements, it's very nice because all of those qualifiers are something that a lot of other knowledge graphs overly simplify. And so being able to get that additional information can be quite nice. And so from here, I'll kind of be covering a little bit about some things to watch out for and things to avoid if you want to try to do queries yourself. So first of all, for avoiding bad queries, I think that the biggest example that I ran into when I was failing to make proper queries was that they failed because they were taking too long to return results. And this was often the result of there just being too many results for it to return. So in order to avoid that, it's generally better to try to do a bunch of small queries rather than a few large queries. And by doing a bunch of small queries, you can also kind of iteratively store some partial results that you get, and then just loop through them to make extra queries as you go. And on that point, it's generally going to be a good idea to try to avoid querying like all incoming relations to a particular entity. This was something that I ran into when I accidentally ended up trying to query for all instances of humans. And there are millions of humans within Wikidata, and so this kind of crashed our BI's instance. So please avoid that. Outgoing entities are generally preferable, and there's usually significantly fewer of them. Another thing that you need to keep in mind is just the aspect of human error. The fact that Wikidata is community driven is great, and it makes it so that there's a lot of human in the data, but the negative side of that is that there's a lot of human in the data, including human error. So just for a couple of quick examples that I tried to find for sending here, the subclass of relation, you shouldn't end up with a cycle of subclasses, but I was able to find 45 pairs of Wikidata classes that pointed to being subclasses of each other. For example, here, the history of science and technology is a subclass of the history of technology, and then the history of technology is a subclass of the history of science and technology. That's just bad modeling. And in other instances, there are just poorly entered pieces of information. Like I found 2 entries where there are entities that are instance of Albert Einstein, which doesn't make sense unless you're considering the person Albert Einstein to be a class. And these couple of examples are some sort of theories related to relativity, which point to being an instance of Albert Einstein. There also are these markings for the statements having potential issues, which I think are probably automatically generated. but I'm not 100% sure about that. And it can potentially take time for these sorts of erroneous statements to be corrected.
I think that sort of error, I think it may ultimately be human error, but you think that it may be like a symptom of some kind of harvesting of Wikipedia or something like that, and just not having been.
Yeah, that could definitely potentially be the cause. And in terms of like this example as well, like say with instance of, because Wikidata doesn't seem to do very strict enforcement of things like say something being a class or not, this sort of error I think can occur fairly frequently just because there isn't a like very easy way to completely automate checking for those sorts of sample errors. But yeah, it is entirely possible that some sort of automated harvesting methods could be entering incorrect information, which then humans would have to go through the effort of tracking down. The next point that I kind of want to raise is that within Wikidata, again, because of the human aspect, there can be some questionable choices of how things are modeled, and also the coverage of various topics. While it's great that there's an extremely wide breadth of topics, the specific coverage for any particular topic can vary quite a lot, depending on really how much effort any particular person has put into curating that data. So in terms of modeling choices, sometimes you kind of need to actually look at the qualifiers for statements to make sense, or for statements to be true anyways. For example, with this disease entity, it has effect relation of death, and then it has this qualifier of rarely. And so that kind of is a little confusing what it really means, especially considering how this disease item is very broad, is not explicitly defined as a class, but we would probably think of it as a class. And so that sort of, it leads to death, but having the qualifier rarely can make it so that if you're just trying to use this direct property, it could be a little misleading. Another example of, say, a very recent event, the Ohio train derailment. This one, we have a few effects that people have entered, and one of the entries here is that it has caused death, but some of the qualifiers specify that it's caused the death of fish. Down the line, unfortunately, maybe it will also include human death, but anyways, this sort of qualifier information can be extremely necessary to understand when some people make these sorts of entries. And so that's something that you kind of just need to be careful about so that you don't overly rely on, for example, just using the direct property statements. And then another questionable modeling decision is that sometimes the granularity of entities and like their subclass relations isn't particularly consistent. So for example, here I have an example of the 2011 Tohoku earthquake and tsunami, as well as another entity that's the aftermath of that earthquake and tsunami. And I at least find this to be a little bit strange in terms of how they're defining the content, because first of all, the Tohoku earthquake and tsunami is defined as being the earthquake and the tsunami, as well as these other things. But it doesn't actually explicitly have any sort of modeling for just the earthquake on its own. And logically thinking about it, the earthquake is what caused the tsunami. And so bundling all of that together into a single entity seems a little bit questionable to me. And then also the aftermath of the Tohoku earthquake and tsunami also is a tsunami instance. And so the granularity that someone decided to actually enter these entities, and whether or not it was a tsunami or whether you should have an additional entity like a tsunami that was caused by this earthquake and so on, is a little weird. And quite frankly, it's slightly arbitrary in my opinion. And so the exact way that people model various things can vary, and this can potentially impact the quality of the data that you collect.
Do you think the entities are coming from the articles in Wikipedia? If they are defined as an article, it's going to be one entity, no matter if they are like earthquake and tsunami?
Potentially, but not necessarily. So not all entries, I think, have an explicit reference to Wikipedia. So for example, this aftermath doesn't have an explicit link.
It's not, so Wikidata is not like DBpedia.
Yeah. Yeah, because DBpedia, if I recall correctly, is like completely automated to pull from Wikipedia entries.
Yes.
Now,
Yeah, I think that there are some aspects of automating it. I'm not actually sure whether it goes both directions of Wikidata getting stuff from Wikipedia and Wikipedia using Wikidata things to present like their information boxes. So there is some automation going on there, but I think that there also is like human decision involved in terms of some business.
Wikipedia's ontology is very, very ad hoc. It's still, it always has been, and it's also, it's an adhocracy in terms of changing it, which in the early days of tetherless, we had a lot of bad experience with demos based on that data and having it change overnight. Between Jim Hendler testing an app in his office and then going to the White House. Having it different. Thank you.
So yeah, the last point that I have on this slide is kind of on the topic coverage. So once again, whether or not detailed information exists depends on community interest. For a significant event like say COVID-19, members of the community can start up like specific projects about, for example, COVID-19, and this can make it so that the coverage of these things can be very extensive, but because the particular choices that these people made, or maybe the level of automation being different and so on, the amount of information that's actually contained within an entity like the COVID-19 pandemic can be slightly overwhelming in terms of what's entered. So the country for the COVID-19 pandemic has every single country that was affected. And then for each country that was affected, there also is its own Wikidata entry for the pandemic in that particular country, which, depending on how much data there was available from the country and their methods that they use for getting this data, there's also a timeline of the number of deaths that goes on quite a lot. And so potentially this could be very useful to have very detailed information if you want something about, say, COVID-19, but this sort of coverage isn't very typical. And depending on the other surrounding information that you're collecting, the fact that this particular entity and related events have so much more data could potentially be problematic for any sort of data pipeline that you're trying to pass it into.
And imagine since in theory, each country is responsible for itself, representatives, community members from each of those countries. If there are particular kinds of data feeds, like cases or whatever, they could be totally different. So
yeah, so I actually think that for that point you made of like people from the country being responsible for it, I think that probably wasn't true for this particular project.
Oh, okay.
I remember someone giving a presentation during the Wikidata workshop and they were kind of covering their involvement with the project. But I think there was more so people that kind of had the motivation to work on the project, went in and put in a bunch of the automation and stuff. And so maybe there was some community support from specific countries, but that's not necessarily true in terms of the people that were working on it. It was very much more a few people decided to make this project, and since it's a community-driven and open source knowledge graph, they will.
Okay, got it.
And so other aspect that I want to touch on is just that you need to be careful what you query for. In a lot of the examples for these problematic queries, it's kind of related to the queries that I did in the past of trying to collect pairs of causal events. So events that were connected by like a has effect or has cause relation. And so I was trying to do this sort of querying so that I had a database of causal events and focusing on that to do some tests. But the ways that these sorts of properties within Wikidata are used aren't necessarily very obvious. And sometimes there's a lot of data that kind of is using it in a different way than you would expect. So as you can see here from this example that I've written out, for causal event pairs, there was a very large amount of entries for some sort of parliamentary process that was going on in the Swedish legislature. So actually, if I go to that.
Crazy sweet.
Yeah, and there must be some automated pipeline for it because it was far too many entries to be something that people put in manually. But so for example, if we do this, so this is the property for has immediate cause, and this is a report. So report from the committee to the Swedish Riksdag with a well-rounded proposal or decision. And so there's 105,000 entries for this. And so obviously that was causing some problems for my data because it was making the vast majority of my data not be event related. If we actually go into inspect a couple examples of this, they also aren't really that useful in terms of the information. So there's no label defined for both of these. This is a motion and it's the other way around. So this is a report and it had an immediate cause, which is a bunch of these entries, which are these motions. And so it seems like there must be some sort of automated pipeline to have in place for every single motion and report that's produced by this. It enters it as like the report having immediate cause, motion, and so on. And so if you don't actually look through your data and spot those sorts of occurrences, it can potentially skew a lot of the data that you have available to you through these queries. Right. Okay. And just as another example that I came across today when I was trying to look at more examples of like causal relations, there's also things like entries for fictional spells in what I was able to figure out is some sort of open source web novel that's published by some guy in France, which it was just really strange to me that I guess the whatever level of popularity that that particular web novel has, someone was motivated enough to make this entry for a fictional magic spell, as well as the effect that it has, which is to create a black hole, apparently. And so being able to actually look through your data and spot these sorts of issues is critical to be able to actually use the data in the way that it's intended. So if you were like me and trying to get a data set of causal events, obviously these sorts of things would be pretty bad to include because it's going to be just additional noise that I'd have to deal with. And for this point, there isn't really any good way to completely avoid it. You can't even really necessarily do something like filtering based on class, just because the way that entries are entered as instance of or subclass of various things can be, once again, slightly arbitrary or maybe even straight up incorrect because of how other people have put it in. And so it can be a little bit difficult to follow any sort of procedure besides just kind of checking by yourself and ensuring that the data's quality is up to par. And so for the last slide that I have here, I basically just have a bunch of additional links for if you want to actually dig deeper and start to try exploring Wikidata or doing your own queries. So there are a very large number of help pages that exist on Wikidata, including on very specific topics. For example, for the problem that I was looking at of causal relations, there's an entire help page for how you should be modeling causes within Wikidata and the relevant relations that you should be using, as well as a variety of examples. And there also is an entire page of a bunch of help pages, which you can search through as well. And so the scope of this is quite extensive. And on a similar note of being extensive, there are a very large number of properties within Wikidata that can be extremely specific to particular domains as well. And you can browse through them, once again, through Wikidata itself. And this browsing is kind of nice because it breaks it down a little bit. So for example, for relations related to humans, there's things like mother, player IDs, population, and so on. A lot of these properties that are within Wikidata are IDs to cross-reference entities between various other databases. And so that can also potentially be a source of noise if you do need to be collecting a lot of information as well. But there are a lot of very topic-specific relations that exist as well, say like with this Greek mythology and so on. There's a bunch of IDs, a bunch of indexes, and also these relations that are kind of specific to things about Romans. So this relation is a standard part of the name of a Roman and so on. And so depending on how much effort someone has put into modeling all of this sort of stuff, there can be some very specific properties that you can make use of. But once again, this is going to be very dependent on what your project or what your use for the data actually is. And so you kind of do have to do a lot of manual labor of digging through a bunch of trash so that you can actually figure out what exactly it is that you need to work with. And then lastly, just pointing out once again that Wikidata's main page has a lot of useful resources. And so if this talk that I gave was completely useless to you, there's entire tutorials that they have on their own page. And so if you ever do need more help, this is a very useful way to do it. For even constructing queries, you're able to get a bunch of help. Like there's a query builder where you can kind of piece it together by putting in properties and so on. This is too clunky for me to find use out of, but if you're not particularly familiar with actually making SPARQL queries, even for that, there is a tool that can help you. So it can be very user-friendly.
The Wikidata workshops series that you've mentioned, there's some great YouTube videos of presentations that people have done also.
Yeah. And so, yeah, with it being so large scale and once again, community driven, that does make it so that there's a lot of help available as well. I'm sure that like if you needed help on anything in particular, you probably could also start a discussion or join their Slack channel and such as well. And so, yeah, that wraps up what I had to talk about in terms of the slides. And so I can just take any other questions that people have, or if anyone's interested in like further examples or how to step through anything within Wikidata, I can also share that.
So let's thank Sola. Matt was talking to. So many of your examples are very, you went through the process of finding like the property identifier type thing. I'm wondering if you could sort of take us through sort of like the process that a person who's kind of familiar with maybe simpler knowledge graphs, more, more conventional structures might try to find Will Smith, stuff related to Will Smith, or how we can kind of go through that.
So actually,
translate that thinking.
In terms of trying to kind of just find some high-level entities or properties, there is also just a search bar up here that can be very helpful for just doing string searches. So like, if you want to look for Will Smith, you can do searches here, and then you can browse through a few of them. If you want to be looking for specific properties, and if you don't want to deal with like that searching for properties, the properties themselves do also come up in here. So like instance of comes up there, or with all of these entries for either where these relations point to or the relations themselves, you can also just click on them directly within this Wikipedia or Wikidata browser, and then it brings you to the page for that particular property. So that can be very useful. The only thing that can be a little bit misleading with just this aspect of like clicking something and getting to it is that for properties, if you're only interested in the predicate object triple of it, just trying to put in like the property that once again is going to bring you to, oh, that's a bad idea. That's going to fail. What was it? Let's go back. And so that query would just return like it failed after a minute or so because I was querying for everything. Yeah. So once again, this is specifically for instance of Will Smith. And so this is going to give you the statement. And so you need to remember that if you do just want the direct property, you have to use the WDT prefix. So that gets you to. Yeah, for the most part, when I was trying to figure out relations to use, I was browsing through like the entities that I was actually interested in the first place and then kind of just clicking through these. And then in some cases also trying to look at like the subclasses or other sorts of relations that connected them. So with the, we look at an example like has effect. There also are additional relations that are related to, like it's a subproperty of followed by, or it has inverse property, has cause, and so on. So yeah, for the most part, browsing through just the website in order to try to find relevant properties and entities, I think is probably the best way to go. And then after you actually figure it out, you can just kind of structure some sort of programmatic query. And actually in terms of querying, one thing that I forgot to include is that if you only want these direct properties, you also do need to do quite a bit of filtering. Since if you just try to do like all outgoing edges, then for the most part, it's going to be those statements that are also included. And for my use case, at least that was undesirable. So I had to do a bunch of additional filtering for making sure that it wasn't a statement or that it wasn't a site link to something else and so on. That can get a little bit tedious if you're being particular about exactly what you want. But yeah.
So the onboarding process kind of starts with playing with the query service.
Yeah.
Just kind of getting used to it.
Yeah, so just speaking broadly in terms of Wikidata's like coverage or quality of data, what kinds of areas would you recommend that somebody use Wikidata, or what kinds of areas would you recommend that they don't? Or I don't know if you could tell me about just like in general, where does Wikidata tend to be strong or where does it tend to be weak?
So, in my opinion, things that are related to people probably is stronger than its other areas, just because so many of the entries are people, and I think it kind of also is reflective of how like a lot of entries in Wikipedia itself is also about people. One area that, well, I guess that there's probably a lot of areas that is weak from my exploration, since so much of it was related to like significant events and trying to query for that. The coverage for that can be very sketchy. Even if there's a Wikipedia article, it doesn't necessarily mean that there's a Wikidata article for it or a Wikidata entry for it. And the granularity at which they capture the information sometimes isn't good. Like sometimes it just has an entry that it exists without any other properties about the event itself. I think that it does have a lot of entries for things like bioinformatics domains. I would imagine that they probably do some sort of importing with other associated knowledge bases. But if you were going to use data that's imported from somewhere else, I feel like just using that other source in the first place might be a better idea, just because then you're at least sure that it hasn't been like modified in any sort of way. But yeah, beyond that, just because like the coverage of the topics is so broad, I can't really comment too much about how well or poorly any other particular domains might be covered.
It's interesting you spoke of bioinformatics, because I follow, there's a couple guys on bioinformatics people on Twitter and Mastodon that I follow. Ego Willingham, something like that. He's from the Netherlands.
Yeah.
But he's very, very active in whatever they're doing in his domain on Wikidata. So the areas like that are being represented. By the way, a lot of their stuff is structured in this way.
Yeah, because like bioinformatics, there are a ton of entries, but yeah, I would just be a little hesitant personally of trying to use it through Wikidata, because if I could get it elsewhere, I would rather just get it elsewhere.
Along that same lines with bioinformatics, myself, I'm working in prebiotic chemistry, and that data is severely lacking both on Wikipedia and Wikidata. Even though there's a lot of bioinformatics information, it's not dealing yet with prebio.
Right.
So that information's missing.
My experience, like non-disputable facts, it's really useful for. So we were trying to scrape synonyms for colleges for like an NLP project, and because we like some people refer to it by location or like short names and stuff, but that kind of stuff was really useful for. But it also had a field for ranking, and that was like inconsistent all over the place, because that's not like something that's set in stone. So even though the value is there, it was highly inconsistent with like a lot of different colleges that have the same ranking, and there'll be no source for it kind of stuff.
I guess fundamentally it's all crowdsourced, right?
Yeah, so anything that isn't a hard fact can be, just to kind of highlight another point that's related to that, for example, for the entry of Earth, there's this highest point relation. And there's 3 different entries here, because depending on where you actually are measuring it from or what frame of reference you have, the highest point can vary. So even for something that might seem more like hard fact, like what's the highest point on Earth, there can be different interpretations of that relation. So even then, sometimes you kind of have to look through the qualifiers that are related to it.
Even Mount Everest there is not bumped up to it.
Yeah, all of these just have normal rank. So because they have these qualifiers of like the determination method for how they're determining it to be the highest point.
What's the centroid method for determining the highest point?
The average position of all points in a shape.
Is that measuring from the core?
Probably.
Because the
Geometric center.
height is less than Everest from the
Yeah.
certified method, so it can't be measuring from the core.
So I don't understand how.
That's height above sea level.
No, well,
Yeah, I'm not entirely
That
sure
is
about
height
the
above sea
specifics of that, but
well, it's almost height above sea level. You're off.
it can have some potential issues as indicated by Wikidata.
It's like baloney. So what are the, are there community ways, accessible community ways to add data to it?
I'm not too sure since I haven't done it myself,
Oh,
so.
okay. I just feel like, I'm recalling when I first was getting on it, I felt like there was like a way that you could, at least with the local instance, it's like a way that you could extending properties. and stuff
Yeah, I
like
think
that.
Yeah, so when I was playing with it, yeah, there's a lot of like softwares that you can actually, build from that, but I don't know if you can re-import it back. You can build from the Wikidata. I don't know if you can import it back.
But when we first set up the instance, we basically, all we had was like the basic Wikidata platform and like nothing. You know,
Okay.
it was like empty. And, oh, there's data too? Oh, I guess we should do that. But it was kind of interesting because you kind of saw, it's kind of analogous to, in a way, to WIAS. They're not the same thing, but they're very similar. In fact, but this whole idea that you got to construct at the levels of indirection and stuff.
Yeah. And also for making changes or additions, like on those pages that I was looking at, say like Will Smith or Earth, those were indicated as being protected, but on a page like this for the much less major event. So I'm not logged in, so I probably can't actually do it, but you can do things like add these values, add qualifiers, add these statements, edit existing statements and so on, so.
Hey, that's pretty cool. And that's like DSpace.
Now that's.
And as with Wikipedia, there's a bunch of history that you can do as well.
DSpace is a 4-letter word. According to Wikidata. All right, so any other questions? So let's thank Sola once again. Thank you very much. Long anticipated Wikidata talk. Please take food with you. If anybody's going upstairs, please haul stuff upstairs, please. Thank you.
Yes.
Thanks.
And give Sola a chance to get some food because he didn't eat much before. And how are we doing on the pies? Eat the pies too.
Oh, pie.
Come on.
No, it's still heavy.
Please take those upstairs along with the server.
Yes.
I think it
Right.
works in.
Funny, when I was sitting in my office,
Yeah,
I heard you come by and say,
Just like, yeah, let me on this.
I'll wait for you to stop recording.